Hi there, and welcome to the first episode of our series From Concept to PCB, where I'll show you how to go from an idea to a functional PCB using the power of CELUS design platform. In this episode, I'll show you how to create your own Raspberry Pi Pico 2 board supercharged with Wi-Fi by using an ESP32 module. Speeding up your project development, CELUS design platform automates component selections, suggests reference designs, and generates ready-to-use CAD files compatible with your preferred tool. Join me to find out more. The Pico 2 is the new Raspberry Pi development board, powered by the new RP2350, a high-performance, secure, low-cost, easy-to-use microcontroller from Raspberry Pi. Available in both 60-pin and 80-pin packaging options, offering flexibility for different design requirements, whether you want to prioritize compactness or additional connectivity. RP2350 features a dual architecture processor, allowing you to use two ARM Cortex cores along with two open hardware RISC-V cores. This enables developers to experiment with RISC-V architecture in a stable, well-supported environment. If you want to learn more about RISC-V and the advantages of this open-source architecture, check out the links in the description. You can also check out this really cool video where CELUS co-founder Andre Alcade talks about the differences of RISC-V against other closed-source architectures, with a large set of peripherals like a programmable input-output port that provides flexible interfacing with no CPU overhead. By using dedicated software programmable state machines, it allows more hardware interfaces to be offered. This means that you can program a controller for a peripheral like an LCD without the need to rely on CPU, especially since it has direct memory access to ensure smooth and efficient data transfers. It also includes standard interfaces like SPI, I2C, UART, PWM, and ADC for interfacing with sensors and other peripherals. Additionally, the RP2350 features a USB 2.0 interface with both host and device functionality, making it an excellent choice for applications that require USB communication without a need for external components. Regarding memory, the RP2350 includes up to 512 KB of static RAM, and up to 16 MB of shipped flash memory via a dedicated CUBO SPI bus. This flexibility means that you can choose the right flash size to store your application while keeping memory access performance by using the static RAM to store program execution data. Designed with energy efficiency in mind, the RP2350 supports multiple low-power modes for extended battery lifetime on portable applications. It also features an integrated core voltage regulator. Using a 2.7 to 5.5 input supply allows you to power your chip directly from a single lithium cell or by USB. This flexibility simplifies power management and makes the RP2350 an excellent choice for a wide range of embedded and portable applications. For most IoT applications, security is important. You want to keep your system safe from attackers while keeping seamless communication amongst other devices. The RP2350 includes essential security features built to protect your system from unauthorized access and data breaches. RP2350 features a secure boot that ensures that only trusted firmware is executed, preventing malicious code from running on your device. Encrypted boot adds an extra layer of protection, making it more difficult for attackers to clone or reverse engineer your device firmware. Trust-zone technology for ARM Cortex-M processors reduces the potential of attack by isolating critical firmware, assets, and private information from the rest of the application. Maintaining two separate execution contexts called the secure and the non-secure domains, important data like encryption keys or systems hardware like the internal voltage regulator is limited to the secure domain, while the non-critical parts of the application are executed at a non-secure domain. As for secure communication and data storage, the RP2350 includes a secure hash algorithm accelerator and a hardware true random number generator, giving you the tools you need to encrypt your data, keeping it secure from unwanted eyes. All these security features make the RP2350 an excellent choice for applications that demand robust security, making it ideal for IoT and industrial. Now, after hearing about all of these features, you might be wondering, how are you going to get them all to work as you need? Developing and programming with this chip is designed to be straightforward and accessible. To get you started, Raspberry Pi provides comprehensive documentation and, being widely recognized and supported by a large active community, ensures that you have access to countless resources, tutorials, and forums, making it easier to troubleshoot your problems and keep your focus on what matters. Additionally, a MicroPython port enables you to run Python 3 code directly via USB serial. So if you're not a fan of C programming, but you still want to create embedded applications, here is your chance. And the best part is a USB bootloader, allowing you to connect your board to a computer as a flash drive. Programming your board becomes as simple as dragging and drop your code into a folder. So say goodbye to that additional programming header taking space on your PCB, because a USB connector is all you're going to need to power and communicate with your board, even programming it. Whether you're building a simple sensor project, an automation system, or even experimenting with IoT applications, the RP2350 microcontroller provides an easy-to-use platform, bringing your ideas to life. While the RP2250 is a powerful microcontroller with impressive processing capabilities, it lacks built-in wireless connectivity. Many modern applications require seamless Wi-Fi Bluetooth communication, whether for IoT, smart devices, or real-time data exchange. This is where the ESP32 models comes in, offering a reliable and efficient way to integrate wireless communication into your project. These expressive wireless modules come integrated with Wi-Fi and Bluetooth dual-core processors and a rich set of peripherals, making it a perfect addition for your IoT applications where connectivity is key. ESP32 models are divided into different families, each tailored to different applications. Some families are designed for high performance, featuring high-speed processors, making them suitable for advanced tasks like running AI models or processing data. Others focus on cost-effectiveness, with features that simplify IoT designs, prioritizing ultra-low power consumption and compact size, ideal for your battery-operated and wearable devices. This diversity ensures developers can select a module that aligns perfectly with their project's performance, cost, and power efficiency needs. The good thing about these modules is that since they're fully working, pre-certified wireless solutions, you can focus on your application development without having to go through the complicated and extended process of certifying your wireless solution, minimizing the risks and costs of deploying your product into the market. And so, by combining the processing flexibility and ease of use of the RP2350 with the wireless capabilities of the ESP32, you can easily create highly functional designs with wireless connectivity for a wide range of applications. The Raspberry Pi robust community support ensures troubleshooting and an abundance of resources, while the off-the-shelf Wi-Fi and Bluetooth capabilities of the ESP32 let you achieve faster development cycles and reduce time to market for IoT applications. And now, let's see how the CELUS design platform makes designing this project simple and efficient. First, go to app.celus.io and log in. If you don't have an account yet, you can register for free. Once you've logged in, you should see this welcome page. To jumpstart our design, we are going to use a feature project. Feature project is a pre-validated design template that provides a solid foundation to build upon. These projects include pre-selected designs, ensuring reliability and reducing developing time. You can find feature projects on the bottom of the main page of the CELUS design platform. Start by opening an existing feature project for the Raspberry Pi Pico 2, clicking on View Project. As you can see, the project comes with a pre-built block diagram representing the Raspberry Pi Pico 2 board. Right-click on any of these blocks and click View CUBOs. The items on this list are CUBOs, and as you can see, this feature project is configured to show you the RP2350 family. To know more about a CUBO, you can click on the Info button from a CUBO on the list. CUBOs include not only the schematic information, but all the data needed for you to make an informed decision and to work with that component. These include the description, the bill of materials, ports, and functional specifications. You can close the CUBO list and go back to the design canvas by clicking on the button on the left top corner of the screen. Back to design canvas. Now that we have the block diagram of the Raspberry Pi Pico board, let's explore how we can add seamless wireless connectivity using an ESP32 by editing this project to tailor our specific needs. The first thing you have to do is click on the copy button on the top right corner of the screen. This will create a copy of the project in your personal workspace, allowing you to make modifications without affecting the original design. Once you've clicked copy, you'll be able to see the design library on the left. The design library includes all the functional blocks that you can add to your project. You can search for a functional block by using the search bar or by using the CUBO AI recommendations. Let's start by adding a wireless communication block to your project. As you can see, our AI assistant is already suggesting the wireless communication block, so let's accept that suggestion by dragging and dropping the block into your design. Now we have to connect this block to the microcontroller to ensure communication and to the supply rail to ensure it is powered. First, we need to create connection points. By clicking on the functional block, you'll see that 4 plus signs appear on each side. To create a connection on that side, just click on the plus sign. In this case, I'm going to create 2 connections, one for the supply and one for the communication to the microcontroller. Now, I need to do exactly the same thing on the microcontroller side, so I'm going to create a connection on the microcontroller as well. To connect these 2 points, I'm going to hover on one of the points and drag and drop it on top of another. In the case of the supply link, you can see that a link already exists. To connect to an existing link, click on it and you can see that an arrow will appear on top of it. If you click and drag that arrow into the connection point of your newly created block, you can see that a supply port will appear. To move this block around, click on it and drag and drop it to the position you want to see. Now you want to specify that the communication between the wireless communication module and the microcontroller is done via UART. To do this, I'm going to right-click on top of the connection, click on Manage Settings, and you'll see on the left that a panel will appear. On this panel, I can click on Select Interface, start typing UART, and you'll see that a UART port appears. Click on it to specify the desired interface. This will be enough to add the Wi-Fi functionality to my board. However, I want to use the QSPI external boot memory functionality of the RP2350. Therefore, I'll also add a flash memory block to represent that same memory. I'm going to do that by using the search bar of the design library. Click on the search bar and start writing flash. As you can see, a flash functional block appears. I'm going to select it by clicking, dragging and dropping on top of the canvas. Now I'm going to do the same thing as I did for the wireless communication block to connect this flash block to the supply and to the microcontroller. After this, we will click on the Resolve button on the top left corner of the screen. This will trigger a search for CUBOs that match the requirements of the block diagram. Once Resolve is done, you'll see a purple light bulb appearing on the top right corner of each block. This means that the solution was found for each block. To see the solutions, right-click on the functional block that you want to see and click on Select CUBOs. You'll see different available solutions for you to choose. You can also use our AI chat assistant CUBO by clicking on the bottom right corner of the screen. You can ask any questions regarding the CUBOs on the list. Due to its small footprint size, I'm going to select the ESP32 Pico Mini 2 board. To select this CUBO, I'm going to click on the Select button on the CUBO and I'm going to click Lock on the model dialog that appears. To return to the canvas, I'm going to click back to Design Canvas. As you can see, the icon on the top right corner of the block has just changed to a green lock, letting you know that you already made a selection for that block. Once you're happy with all the CUBOs you selected, click on the Resolve button once more. This will prepare the project files for exporting. Once done, click on Output Files. Here, you can export all the necessary project files in just a few clicks. You'll see sections for a PDF, a bill of materials, and CAD files. Click on the Download button to retrieve the files. In the case of the CAD files, you can select your preferred CAD tool from the drop-down list next to the Download button. The PDF includes all project details, from descriptions and settings to schematics for each selected CUBO. In the end, you'll also see a bill of materials. As for the CAD files, they are ready to open on your selected tool. As you can see, you will not only get the schematics for each CUBO, but also all the footprints and a preliminary layout. Now, all you have to do is start designing your board. And there you have it! We've introduced you to the key components of this project and shown you how the CELUS design platform sets you up for success. In the next video, I'll dive deeper into CAD integration and PCB design using Fusion 360, a powerful tool that combines electronic and mechanical design in a seamless workflow, allowing you to refine your board layout, verify component placement, and ensure manufacturability. I'll show you how to go from CELUS design platform generated CAD files to this board using Autodesk Fusion. Don't forget to like, subscribe, and hit the bell button to stay updated with our latest tutorials and insights. By subscribing, you'll gain access to exclusive tips and in-depth guides to help you accelerate your electronics projects. Thanks for watching, and I'll see you in the next video. Bye!